Okay, well, yeah, so so we have 2 more pages to go through. Let's go ahead and do that. So number 4, particle, position, this function, find the displacement. Right, so this is really very similar to, I would say, this previous problem that we went through. So the displacement, the way you would normally write that is s of pi minus s of 0. And if you think through the fundamental theorem of calculus part 2, that's the same as the integral that you would form from 0 to pi of, and then in this case, it would be s prime of t. So we would just copy down the function here. And well, this time we had to just integrate this. So this would become -3 cosine of t, and we want to then evaluate this from 0 to pi. Okay. And so, right, we can evaluate this. Cosine at pi is going to be -1, and at 0 is going to be +1. But since we are taking the difference of the two things, we end up with another -1. And so then this ends up being 6. And our units in this case should be feet. And so this is actually displacement. So the left-hand side here, that subtraction is the displacement. So that's how we arrive at the answer. Okay. 5 is very much the same. This time it actually tells us the initial. So if we wanted to translate this into symbols, we could use P of t to denote the population. And the first sentence is saying that the rate of change is actually the derivative. So p prime of t is 2e to the t, and that p at 0 is equal to 100. So we want to figure out the size of the population after 10 days. That's p of 10. And since we have 2 different points in time, it would make sense to plug in p of 10 minus p of 0, which is then going to be the integral from 0 to 10 of the p prime dt. Okay, and so we can integrate that to e to the t, evaluate this from 0 to 10, and plug in. So when we plug in, we'll get e to the 10 minus e to the 0, which is just 1. And well, we can still work with this symbolically, because actually the last thing we want to do is actually solve for p of 10. We know that p of 0 is equal to 100, so we'll have 2e to the 10 minus 2 plus 100. So you could write this, if you didn't have a calculator, you could write this as 2e to the 10 plus 98. If you had a calculator, you could then approximate this as being 44,151 insects. So I guess I'll box both of those. Any questions so far? No? Okay. Probably should charge this. All right. Number 6. Okay, so W is the rate of water flow. Okay. And so it makes sense that we're integrating this rate. Okay, then we talk about what it represents. So first we just calculate what this integral actually is. Right. So integral from 1 to 10, 2 minus t over 100 dt. Well, so the integral of 2 is going to be 2t. The integral of this t over 100 is t squared over 200. And then you evaluate this from 1 to 10. So that's going to be 20 minus a half, and then subtract off the evaluation at 1. So that's going to give you 2 minus 1 over 200. Okay, well, doesn't look very, yeah. You could at least do this much mentally. So 100 plus 1 over 200, just by combining the fractions. But to get a decimal approximation, might need to use a calculator for that. And so you get 17.505 gallons. Okay. So now interpreting what this integral actually meant in words. So W is the flow rate out of the storage tank. So by taking the integral of it, what we're doing is pretty much we end up measuring the total volume of water that has flowed out. So this is the amount of water that flowed out from minute 1 to minute 10. Since the two points in time are 1 and 10, that corresponds to minute 1 and minute 10. Okay. And we have no problems, right? So for 7, marginal cost, that just means it's the derivative of the cost. Pound. Okay. Pound is measuring the amount of chemical. Okay. How much extra does it cost to increase the production from 5,000 or 500 to 5,000? Okay, so you know that is really the normal way you would write this is C of 5,000 minus C of 500. That would measure how much the additional cost actually is. And you know that one way to get to this difference is by using the integral from 500 to 5,000 of the C prime function, which is this negative 0.05, 0.001 x dx. Okay, so if we go ahead and integrate this, well, it really doesn't evaluate nicely. I definitely did not want to compute this by hand. So 0.001x squared over 2. And then you want to plug in these two values. Okay, so if you do it step by step, if you do one evaluation minus the other, you'll get 12,250 minus 100. So the final thing you end up with is 12,150. Right. And then part B, suppose the cost of producing 0 pounds is 6,000. Find the function for C. Okay, so that's related to the first, definitely. So the only thing is we're not really dealing with the subtraction and we don't have a definite integral anymore. So instead, C of x is just, as you know, it's going to be the integral of the C prime. function. Maybe I can just write that like so, because we pretty much, we found the antiderivative. It's just that in this case, we'll have a plus c instead of this evaluation. So you know it's minus 0.05x plus 0.001 x squared over 2, and then plus a constant. And then the problem tells you that you have c at 0 is equal to 6,000. So c at 0, which you can look and see that that's just going to give you the value for c is supposed to equal to 6,000. So the constant is 6,000, which means that our function is just going to be everything up there except replacing the constant with its value. So there it is. Okay. For number 8. So we need this graph. Find the displacement from t equals 0 to t equals 6. And this graph is denoting s prime, so it's the velocity, okay? And it has the initial condition, but part A doesn't use the initial condition since it's only talking about the displacement. So it's displacement just means it's going to be the difference in the positions. So it's really only asking us to calculate this, which we would then rephrase this as the derivative, or sorry, as the integral of the s prime function. And we can just figure that out by looking at it visually, I think. So how do I want to explain this? I think, yeah, I think the easiest way is to just kind of notice that these shapes are, so this triangle and this triangle will cancel each other out, and this triangle and this triangle will cancel each other out. So you can check that the bases and heights are the same for both of these pairs, which means that when you take the integral from 0 to 6, you end up with 0. Okay, so yeah, the displacement is 0 feet. For B, the ending time is actually different, so we can calculate that I guess slightly differently. The position of the particle at 4 seconds. Well, you could write this. Probably you could write this in the same way. I don't seem to have done it that way though. So, well, 0 to 4, this time we don't fully cancel. So we end up with a negative half times 2 times 4. So that's a negative 4. We end up with a displacement of negative 4. S of 0 is 6. So S of 4 is going to be 6 minus 4. So we end up with 2 feet. So this is the position that you end up at for t equals 4 seconds. Okay. Well, that felt really fast. Are there questions on anything?
On number 6, just kind of like a technical question. So we're talking about from 1 to 10 feet. If the question was worded differently, like if it was the first 10 minutes, would that be the same as going from 1 to 10? Or would you start from 0?
I think that would be starting at 0. Yeah. The question is then, do you want to include 10 or not? 0 to 1 is 1. Yeah. So okay. Yeah. So 0 to 10 would be the first 10 minutes.
Okay. Thank you.
Yeah. Okay. Okay. Other questions? Okay, well, then I guess I'll see you guys next week.